Saxon Algebra 1, lesson 107. This is a gem, you guys. This is a classic that's going to go down in your algebra history of one of the gems that will show up on standardized tests. If there is even standardized testing in the post-COVID world, nobody even knows what's going to happen. Those families, those celebrity families that cheated and got their kids into school, some of them by buying off like SAT results tests. Do you know what I'm talking about? I can't think of their names right now, but one of the moms was in the original Full House. I know, it's a newsworthy topic. But anyway, they cheated. These families did. That mom in particular didn't. They cheated in a different way. But some of these people used the SAT to cheat, and it's making colleges just rethink whether they should even bother with standardized testing as an entrance for new students. And so these cheating families may have done not only society, but you guys in particular, a huge favor by removing standardized tests. I'm not a fan of them. I think class grades are a much better indicator. So anyway, that's a whole long roundabout way of saying maybe you'll take the SAT, maybe you won't. But if you do, problems like this will probably be on it. What we're going to talk about is the slopes of parallel lines. Okay, so here's a little graph, okay? And we're gonna plot a line on it just randomly. I'll make it go like that, okay? So this line, this is the x-axis, this is the y-axis, this is our line. I don't care what the equation of that line is. It's y equals mx plus b, right? We know it's gonna be in that format. We know that m is gonna represent the slope, the tippedness of the line. It could be a positive slope going up with the little car going up the hill, or it could be down, a little car going down the hill. This is a positive slope. And we don't know the slope, but we can just see it in the picture. Now, what if I draw a line that is parallel to it? Doing my best to make it actually look parallel, but pretend it's perfectly parallel. That's not bad. But pretend it's perfectly parallel. What that would tell us is that it has the same slope, right? I know you're grabbing paper and pencil and writing this down too. Parallel lines have the same slope, but now let's look at the y-intercept. Okay, they have a different y-intercept. The y-intercept difference defines the space between the lines, but they have the exact same degree of tippedness, to use a non-mathematical expression. So they have a different y-intercept. Okay, this puffy cloud of knowledge is hugely useful to us, because if we're trying to find the slope of a line and we find out that it has a parallel line, then we can just take the slope of the parallel line and use it for our line, right? It saves us work. So let's look at an example, 107.1. We're getting so far, you guys. We're very near the end. Find the equation of the line through this point that is parallel, that's my sign for parallel to, well, it's not my sign, it's the mathematical sign. For parallel, it's parallel to 4x plus 3y equals 7. Okay, this is useful information. This is super useful. So our line passes through this, but it's also parallel to that. Now we only have 1 point, so we couldn't use that this formula. We can't use that because this requires 2 points, 2 pairs of points. And in this problem, we were only given 1. So we can't use that. the slope formula. We can't use this formula, the slope formula, because it requires 2 pairs of points. We only have 1. So somehow we have to extract some information out of this. Okay, we know that this is a line that is parallel to our line, if you will. Oh, and we remember this, parallel lines have the same slope with different y-intercepts. Okay, different, I spelled that wrong. Beautiful. Catch my mistakes eventually. It's hard to do this by myself because I don't have anyone else helping me, running their eyeballs along it. So I have to catch my own mistakes. Gosh, I'm working so hard, you guys. Okay, so we look at this and we go, oh, we want the slope. Oh, the slope is the number in front of the x term, right? So it would be 4. Wrong. Wrong, wrong, wrong. Because this tricky little beast is not in the proper format. Proper format, you say? What's the proper format? Oh, y equals mxb. So we have to take this equation of the line, before we start plucking out any numbers and calling them the slope, we have to get it into what we call slope-intercept form. Right? And that's y equals mx plus b. So we have to rearrange this. It's not hard to do it, but we just have to make sure that we do it. Did that even make sense? 4x plus 3y equals 7. I'm copying it over. So we want to subtract the 4x. That will give us 3y equals minus 4x plus 7. And then we want to divide everything by 3. So we get y equals minus 4/3 x plus 7 over 3. Don't let the fractions put you off. Okay, so this is what I call the other line, right? It's the one that's parallel to ours, but it's not ours. Now, because we know they're parallel, we can take that slope. And I can write our slope equals minus 4 over 3. Okay, so this was the first step. Find slope of the other line, right? And then that tells us that our line is the same slope because they're parallel. And then for the second step, I am so running out of space. Plug in m, x, and y to solve for b. I'm going to do that on the other page, but let me just explain. Now that we have m, we also have an x and a y. We don't have to number them 1 or 2 because we only have 1 pair of points. So now we can take this m, this x and y that we know are on our line, and we can plug it into y equals mx plus b and solve for our line. So let's see. I have to remember those 2 numbers and minus 4/3. Okay. Minus 1 minus 3 and m equals minus 4/3. Okay. This is the x, this is the y, and we're going for y equals mx plus b. This is step 2 continued. So now I'm going to plug these 3 pieces of information into this. Y equals m, well, let's make it big, it's a fraction, times x plus b. Okay, minus 3 equals, and the minus 1 goes there, the minus 4 over 3 goes there. B is what we don't know. Okay, perfect. So now we just have to solve this. This becomes positive 4/3, right? And I can cross that out because we've multiplied it. So I need to subtract 4/3 from both sides. I'm going to have to change this 3 into an improper fraction that has a 3 on the bottom, so that would be 9/3. Negative 9/3, right? This cancels. Draw a big fat line. this becomes minus 13 over 3 equals b. It's okay if we get fractions because we're just doing calculations. We're not going to try and graph it. It's not that big of a deal. So don't let the fractions put you off. Like back here, when we calculated we cleaned up the format of the quote-unquote other line, and we came to this fraction for the slope. Don't let that make you feel crazy. It's fine. It's not that hard to deal with. The only thing we had to do was just convert minus 3 into a fraction with 3 on the bottom. Oh, I think you can do that. It's not that bad, right? There's far harder things you figured out how to do. Okay, so now we have all the information we need, and our final answer is y equals minus 4/3 x minus 13 over 3. It looks, like I said, a little scary. That 13 over 3 makes me uncomfortable, but you know what? It's fine. We're done. Yay! Okay, that is the first part of this problem, or this lesson. That was the harder part. Now we're going to do part B, which is so easy it almost confuses me. It's kind of like a joke. Example 107.2. Here's how this one is worded. Find the equation of a line that passes through point 3, 4 and has a slope of minus 3/4. Last time we had to take the equation of a parallel line and figure out the slope. This time, John just gives it to us. He just tells us that's the slope of your line. Okay, that means we can skip the whole first step that we just did, right? We don't even have to do any of this stuff because the whole point of this was just to find the slope of the parallel line. This time, John's just telling us that's the slope of your line. That's a point that it goes through. Okay, so that means we only have to do the second part. So we just fill it into, I write my formula every time just so I don't confuse myself. Bucket it up, make a big one for M. B is what we're missing, so I'm going to put in this for the Y, this for the X, and this for the M. We're only doing the second part of the problem. It's so much easier. I just love it. Okay, so this becomes minus 9 over 4. I'm going to cross all that out because that's what it's all equal to. So then I'm going to add 9 over 4 to both sides. And this will cancel. 4 needs to have a denominator of 4, so that becomes 16 over 4, right? I multiply top and bottom by 4. 16 plus 9 is 25 over 4 equals B. So now there's my M, there's my B. Y equals minus 3/4 x plus 25 over 4. That's our final answer. Yay. So what's weird is that in this lesson, the first thing we learned is actually way harder than the second thing. But now we're going to do more of the second thing just to make sure you've got it. What we're going to do is we're just going to make the numbers a little bit bigger. This chair isn't the squeaky one. There's one chair that squeaks every time I stand up and sit back down again, which I do whenever I flip the book to make sure I'm still in the camera range. Because wouldn't that be bad if I taped a whole video and you couldn't read the book? That would be bad. But in any case, there's one of the chairs at this table that squeaks every time. Okay, 107.3. Find the equation of the line that passes through the point minus 5, 11, and has a slope of 1 over 7. All right, John's given us the slope. We don't even have to worry about it. We just remember this is x and y. Y equals mx plus b. This is a fraction, so I'll make it big. We plug in, y is 11, x is minus 5. I'm going across. There's different ways to fill it in, whatever makes sense to you. Okay, so this becomes minus 5 over 7. And I'm going to add 5 over 7 to both sides. right? This cancels that way. This needs a denominator of a 7, so it's going to become 77 over 7. Multiply top and bottom by 7. 77 plus 5 is 82 over 7 equals b. And now I can write y equals 1 over 7x plus 82 over 7. And this is the way John shows the answer, but very often when the numerator of the slope is a 1, people will write it like this. I'll write it down a little bit. X over 7. Right? That's usually only done when the numerator is a 1 and they just kind of multiply the 1 times the x and squish those together. I prefer this so I can see my slope nicely. But if you see it in this form, don't let that throw you. You can just pull those apart if you want, right? Just kick the x over to the side and put the 1 in. That's perfectly fine. Okay, 107.4. Let's do another one. This is the last one. And here's it's not hard, but this is what's a little crazy about this one, is look how big our numbers are. It's fine. The slope is -1/2. Don't let big numbers scare you. It works just exactly the same. We've got an x, we've got a y, we've got a y equals mx plus b. I'm not gonna write it again since it's right here on my page. Y equals m, I make it big for a fraction, x plus b. B is what we're trying to solve for. Y is 40, x is -50, and b is -1/2. Okay. So far, so good, right? We've plugged everything in. Buckets are essential in this because we've got minus signs floating around. We don't want to mess those up. Okay, so this is going to become positive 50 over 2, which is also equal to positive 25. So I'm going to cross off everything else and leave that as positive 25. Then I'm going to subtract 25 from both sides. That cancels. 40 minus 25 is 15 equals b. And now there's my m and there's my b, so I can write y equals -1/2 x plus 15. And that is the right answer. And remember, what the equation of a line means is that we can pick any point we want for x, calculate the value for y, and all of those points will fall upon the same line. So just pretend that's the name of this line. I didn't graph it really perfectly, but just pretend. Any value I pick for x and then calculate the y, they'll all be on that line. Isn't that weird and cool in kind of an interesting way? Equations of lines, sometimes we do the calculations, but we don't really think about what they mean. So every once in a while, I want you to just stop and think, what does this even mean? This is the formula that will give us any single point on this line. We choose an x value, we calculate the y value, and if we go to graph that point, it'll already be there on that line. That's kind of cool. I think it's cool. Whatever. Humor me, you guys. It's cool. Okay, that's the end of lesson 107. Goodbye.